This is Mr. Ashton going through the Mathematics Numeracy Unit 2 Calculator Allowed higher tier paper from the autumn and November of 2018. Okay then, so the first question I'm going to go through on the higher paper is question 7, which is on page 12. If you want access to the first 6 questions, it's the last 6 in the intermediate paper, so I'll put a link below and just fast forward the video through to the last 6 questions of intermediate. Okay then, so question 7 says, Danielle is studying the growth of the population of Wales. She used the 2001 and 2011 census data to draw these histograms. Now, as soon as you're seeing the word histograms here and seeing on the y-axis frequency density, I'd be thinking of this formula here. Frequency density is equal to frequency divided by class width. Now, in terms of having this written out, I do it in the same way as the speed, distance, time triangle, because you often have to rearrange the formula. And by writing it in the triangle like this, it will help you do that, okay? Now, there's no questions on this one. So if I come across to page 13, it says, use Danielle's histogram to answer the following questions. Circle the earliest decade in which anyone included in the histograms could have been born, okay? Now, looking at the 2 histograms, I can see there that this goes up to 90-year-olds, and the one below also goes to 90-year-olds. So then I look at the 2 histograms there, and the earliest anyone could be born is 2001, take away the 90-year-old. So 2001 take away 90 gives me 1911. And then this one here would be exactly the same calculation. It's the 2011 take away 90, so it would give us an older decade. So the earliest anyone could have been born was this decade here. The next question says, from Danielle's histogram, the population of under 50s in Wales was 1,870,000 in 2001. Calculate the increase in the population of under 50s in Wales from 2001 to 2011. So to do that, I need to go and work out what the population of under 50s in 2011 is. So 50 would be in between 40 and 60 there. I'm interested in knowing the number of people in each of these bars. So this bar, this bar, this bar, and this bar. Okay, so to do that, I want to work out frequency. So if I come back to the top of the page there, if I cover frequency, I do the frequency density times by the width of the class to work out the frequency, the number of people in that bar. So the width of this bar, the class width is 20, it goes from 0 to 20, that's 20. And it's 6 little squares up from 30,000. And I can see that one block goes up in 10,000, so each square must be worth 1,000. So this would be 36,000 times by 20. So 36,000 times by 20 gives me an answer of 720,000 in this bar here. 720,000. This bar here goes from 20 to 30, so that's a width of 10. And its frequency density is 40. So times those two together, I get 400,000. This bar here is 36 times 10, so that would be 360,000. And then this bar here goes up 3 little squares, so that's going to be 43,000 times by 10, so that would be 430,000. So now I need to add together all those numbers. So 720,000, add 400,000, add 360,000. And then add 430,000. And again, use a calculator to add those. It's a calculator paper, it's not worth the risk. So 720,000, add 400,000, add 360,000, add 430,000. Comes to 1,910,000, full stop. Okay, now I was asked to work out the increase. So the increase will be the difference from what it was there to what my new figure is. So it'll be 1,910,000, take away 1,870,000. So you can use a calculator again to work that out. I've worked that out as 40,000. Okay. We're then asked part 3. It says that 60 to 69-year-olds saw the biggest increase in the population between 2001 and 2011. Calculate the percentage increase between the percentage increase in the number of 60 to 69-year-olds from 2001 to 2011. There's a couple of things we need to know here. Percentage increase requires me to know a formula which is as follows. It's the difference between the years divided by the original number and times by 100. Now, that's something that you need to know. That's a formula you need to know to work out percentage increase or decrease. Now, we're interested in the number of 60 to 69-year-olds, so it's this bar explicitly here and this bar here. So we can see this bar's higher this time. So, in 2001, you can see it's 30,000 and a width of 10 would tell me that there's 300,000 people in that bar, and here it goes up to 38,000, so then times that by 10 would be 380,000. So we do the difference, so 380,000 take away 300,000, so that's 80,000, divided by what it was originally, so it's the amount of people in 2001, so 300,000, and then times that by 100. Okay, so into my calculator, fraction button, 380,000, take away 300,000. Be absolutely fine to just write 80,000 into that if you prefer. Divided by 300,000 times by 100. Now that times by 100 should not have gone there. I'm just going to delete that and move across to the side. There we go. Times by 100 should go there. SD, and I get 26.6 reoccurring. But I'm pretty sure, yeah, it said in the question, round this to the nearest whole number, so that would be 27%. Okay. Over the page, on page 14, it says age group 90 and over, population in 2001, population in 2011, and we can see it's gone up again. It says the data in this table was also available to Danielle. Explain why Danielle did not include this data in a histogram. Well, the formula for the histogram is frequency density is equal to frequency divided by class width. Because it's 90 and over, we don't know what the class width is, so therefore we can't use the formula. So as there is no class width for 90 and over, it is not possible to calculate frequency density. Okay, and it then says the number of 40 to 49-year-olds in Wales in 2011 was different to the number of 30 to 39-year-olds in 2001, so 10 years beforehand. Give a full explanation to what could have caused this. But let's just go and double check where they are. So we're looking at 40 to 49-year-olds in 2011. So 2011 there, 40 to 49-year-olds, so that's 430,000. And 10 years before, they would have been 30 to 39-year-olds, so this bar here. Okay, so let's just double check how many people in this bar. You can see that it goes one square on, so it'd be 410,000. And now it's 430,000. So 2001, 410,000. 2011, it's gone up to 430,000. So what could have caused this? Well, people relocating to Wales, okay? So more people moved to Wales than left the country. Okay? Okay, then, over the page, the question on standard form. Have a quick read of the question. I think it's a very, very tricky question. Have a quick read of it, and then I'll start going through it in a minute, okay, or in probably about 10 seconds. Okay, then, so question 8 says, Helen is the captain of a cargo ship. She's planning her next voyage. Helen has been employed to deliver 3 times 10 to the power of 5 tons of sand. Helen needs to know the volume of the sand before it can be loaded onto the ship. She has been given the following information about the sand. Mass of a grain of sand is equal to 1.2 times 10 to the minus 3 grams. Volume of grain of sand is equal to 0.32 millimeters cubed. Calculate the number of grains of sand in 3 times 10 to the power of 5 tons of sand. Give your answer in standard form. Now, there is an issue with this straight away. Okay, there's a lot of information going on here that we've got 2 things here, this thing here, tons, volume, and so on. Okay, now, first of all, we're asked to calculate the number of grains of sand with tons. Tons is a weight, so I'm looking at a mass. So I want to work with this this bit of information here. Nothing to the volume yet. Okay, now, what this statement is saying here is saying that 1 grain of sand, so I'll just say 1 sand, is equal to 1.2 times 10 to the minus 3 grams. It then wants me to work this out, but in tons, okay? Now that's an issue. They cannot be in different units of measure. They need to be in the same unit of measure. So just working up here for a second, I'm going to write down the following. 1 ton is equal to 1,000 kilograms. That's a definition that you should know. Another definition you should know is that 1 kilogram is equal to 1,000 grams. So to change tons into kilograms, I would times by 1,000, and to change kilograms into grams, I would times by 1,000 also. In other words, to change tons into grams, I need to times by 1,000 and times by 1,000 again. I need to times by 1,000,000. Now that has got 6 zeros, so it's like saying times by 10 to the power of 6, okay? So when I say here, where is it? I want to change this. I want to work out how many 1.2s fit into 1.2 times 10 to the power of minus 3 fit into this. I've got to have it in the same unit of measure. So I'm going to times it by 1,000,000 to change that from being in tons there to now in grams, okay? And to do that, I'm just going to add the powers of the indices, okay? So 3 times 10 to the power of 11 grams is the same as saying 3 times 10 to the power of 5 in tons, okay? So now what I'm trying to do is to work out how many 1.2s times 10 to the minus 3 fit into 3 times 10 to the power of 11. Now, put it this way. If I told you that one red blob, so have I even got a red blob? Let's say that one red, this thing here, is equal to £6, and I'd spent £30 on these red highlighters, okay? You'd say, how many highlighters did I get for that 30? You'd say, how many 6s fit into that? You'd do 30 divided by 6 and say, 5 times. So that must be 5 red highlighters cost that much. Now, it's a bit of a strange case that I've given, but hopefully what it's making you see is that I do the bottom bigger number divided by that number to work out what I've times it by, and I do the same to both sides. So what I need to do is the same idea here. I need to know how many 1.2s times 10 to the minus 3s fit into 3 times 10 to the power of 11. So what I'm going to do for that is press the fraction button and say 3 times 10 to the power of 11 divided by 1.2 times 10 to the power of minus 3. And I find the answer is 2.5 times 10 to the power of 14. So I've times this small, tiny number by 2.5 times 10 to the power of 14 to get 3 times 10 to the power of 11. Whatever I do to one side, I do to the other. So in terms of the grains of sand, the total grains of sand I have, 1 times anything is going to stay the same. I have 2.5 times 10 to the power of 14 grains of sand. Okay? Now, the next question tells me that, let's use a highlighter I've not used yet, that the volume of a grain of sand is 0.32 millimeters cubed. Then says calculate the volume of 3 times 10 to the power of 5 tons of sand. Now, it then says it wants it in meters cubed. Now, something that we need to just get our heads around quickly. I'm going to draw a cube, which is going to measure 1 meter by 1 meter by 1 meter. So the volume of that is 1 meter cubed. Now I'm going to go and draw another identical cube to it, but this time, rather than measuring it in meters, I'm going to measure it in millimeters. To change a meter into centimeters, you times by 100. So to change centimeters into millimeters, you times by 10. 100 times by 10 is 1,000. And you should know that 1,000 millimeters fits into 1 meter. Milli does mean 1,000. That's the prefix for it, okay? So that would be 1,000 millimeters as well. And this would be 1,000 millimeters as well. The volume of this cube, which is identical to this cube, but measured in millimeters, would be 1,000 times 1,000 times 1,000. 1,000 times 1,000 times 1,000 is equal to 1 billion millimeters cubed. And I can put it equal to that because I know that it's exactly the same cube. I've just measured it in millimeters rather than measuring it in meters. Now, to change meters into millimeters cubed, I would times by 10 to the power of 9 times by 1 billion. And to change millimeters cubed into meters cubed, I would do the opposite of that, which is dividing by 1 billion. 1 billion divided by 1 billion will give me 1. Okay, So to change millimeters cubed into meters cubed, I would divide by 10 to the power of 9. We're then told that 1 grain of sand, one sand, is 0.32 millimeters cubed. Okay, I know that I've got 2.4 times 10 to the power of 14, so 2.5 times 10 to the power of 14 grains of sand. How big is that? Well, what I need to do is times both sides by 2.5 times 10 to the power of 14. So here, I want to do 0.32 times by 2.5 times 10 to the power of 14. And that tells me that it's 8 times 10 to the power of 13 millimeters cubed. But the problem is that this is in millimeters cubed, and it's asked for it in meters cubed. So change it from millimeters cubed to meters cubed, follow this arrow here, so I would divide that by 10 to the power of 9. So I'd say 8 times 10, or I'm just going to say 8 times 10 to the power of 13 millimeters cubed, divided by 10 to the power of 9. So here on my calculator, divide by 10 to the power of 9 gives me 80,000. Okay, I could put that in standard form if I wanted to, but there'd be no need as it hasn't asked for it in the question there, okay? But it would just be 8 times 10 to the 4. Okay? Over the page, it says, Helen is given the following instructions for her voyage. From Port A, sail 200 kilometres due south of Port B. From Port B, sail due east to Port C. And from Port C, sail on a bearing of 318 degrees back to Port A. Use the space below to draw a sketch of that. So I'll give you 5 seconds, pause the video, have a go at it. I'll start going through it in about 5 seconds. Okay then, so the first thing I'm going to do is write out never eat shredded wheat here to remind me of my compass directions, and then I'm going to start drawing that out. We go from Port A, here we go south 200 kilometres, so I'm going to draw a line and I'm going to call that Port B, and that in my drawing is equivalent to 200 kilometres. I then go due east for however long, I don't know, I'm just going to draw something and I'm going to stop and just have a guess because it doesn't tell me how long that is. That's Port C. So I've dealt with that and that. Then it says from Port C, sail on a bearing of 318 back to Port A. So from Port C, I'm going to draw a north line there. 318, that would be 90, 180, 270, 318 would be somewhere in here. So back to Port A. So if I join those up there. Now, if that's 90, 180, 270, to work out what is this bit here, I'm going to do 318 take away 270. I know that this angle here is 48 degrees. Now within here, I've drawn a right angle triangle. We know that degrees there is 90. I'm asked to go and work out the distance from Port C back to Port A. It wants me to know how long this line is. Now, what they're expecting me to realise is that I'm using trigonometry here. This would be the hypotenuse as it's opposite the right angle. I would call this side the opposite of the angle. And then this side is next to the angle, I would call that the adjacent side. Because I want to know this side here, I'm going to underline it. And because I do know how long this side is, I'm going to underline it. I'm now going to write out Sokotoa. I'm going to cross out anything with an O and an H in it. I could stop there because that's already double crossed out, but if I carried on, you see it's the only one that's double crossed out. And that reminds me what the formula is. Sine angle, so sine 48, just the angle inside the right angle triangle, is equal to the opposite side, so 200 kilometres, or just 200 for now, I'll worry about the kilometres at the end, divided by the hypotenuse. Now I want to get that hypotenuse by itself, so I'm going to take it to the other side where it's going to times the sine 48. That's equal to 200, and then to get the hypotenuse by itself, I'm going to get rid of times sine 48, and I'm going to take it to the other side where it is going to divide by sine 48. Okay, now to do this, just literally sticking it into my calculator, 200 over sine 48, and I press the bracket there, and I get 269.1 kilometre to 1 decimal place, but no reason why you couldn't have gone 2 because it didn't tell me to go to a certain number, okay? So 1 or 2 decimal places there. Okay, question C. Question C says the last time the cargo ship was unloading sand in the port B, it took 3 cranes 45 hours to unload 250,000 tonnes. We're then asked that we're then told that port B now has 5 cranes. Calculate the time it will take 5 cranes to unload 300,000 tonnes of sand. You can assume all cranes unload sand at the same time and at the same rate, and everything else stays the same. Give your answer in hours and minutes. Okay. Now, going back through, read the first bit here. We're told 3 cranes, so look for the numbers and what is given straight after it. 45 hours, 250 tonnes. Okay? We're going to write a table. Here's going to go cranes, here's going to go hours, and here's going to go tonnes. Cranes in port B was 3, hours is 45, and then tonnes of sand, 250,000. That was the first time we went. The second time we're going, we now have 5 cranes. So under cranes goes 5, and then unload 300,000 tonnes. 300,000 tonnes goes there. And we're asked how many hours will it take, okay? Or how many hours and minutes. So I'm going to just call that X, okay? Now, what we do is where we're told the information is we're going to write it once where we write it as a normal fraction. So the small one over the big one. And then underneath, we're going to write it as the big one over the small one, or what we call the reciprocal of that fraction. Here, we can't do that because we don't know both numbers. And here we can do it because we do know both numbers. So you do the small number on top to begin with, so 250,000 over 300,000. And then on the next line, you do the flipped version of that, which we call the reciprocal, so 300,000 over 250,000. Now, we know that we have 45 hours to begin with, and we want to find out how many hours it's going to take now. So what we need to do is use logic to trace our way through these steps. If I had 3 cranes, and now I have 5 cranes, is that going to take me more or less effort? Well, if I had 3, and now I've got more cranes, it's going to require less effort per crane. So I choose the lesser fraction, the smaller fraction, okay? Then coming to here's the tonnes. I had last time 250,000 tonnes. I now have more tonnes to shift, so will that require more or less effort? The answer would be more effort to be required to shift more weight. So to work out what X is, I need to just follow that path. I need to do the 45 times by the 3/5 times by 300,000 over 250,000. I press equals and I find out what X is. I find out how long it's going to take me. It takes me 32.4 hours. Okay? Now, they want the answer in hours and minutes, so I can put in what the hours are, 32 hours. To work out what 0.4 of an hour is, that would be 0.4 times 60 minutes in an hour would be 24 minutes. So 0.4 times by 60 told me that bit there. Okay then, over the page. Have a quick read of the question. I'll start to go through it in a moment. Okay then, question 9. It says, a train manufacturer has developed a new braking system. The velocity time graph shows the velocity of the train from when the new brakes are applied until it comes to rest. Estimate the train's deceleration at 60 seconds. To do that, find where 60 seconds is on the graph, fire up until you hit it. Okay? You go and draw a blob there with your pencil. Okay? Now, to do this, I'm going to draw a tangent at that point. So a line, a straight line, that only touches the graph in one place. Okay? Now, when I draw this tangent, I always think of a bow tie. Now, when a bow tie is worn, you will have roughly the same amount of area each side of where they meet. We would not want a lopsided bow tie that looks something like that or something like that. Okay? So when I try and get my ruler, when I put it there, I can see that I've got hardly any area at all this side and loads here. I try and match that out. Now, forget about what's going on up here. It's just immediately after the graph, okay? So I'm looking to draw a line that looks something like that. And you can go right from the edge to the edge, okay? I think that looks like a fair amount of area each side. Forget what's going on up here and what's going on down here. It's just this bit immediately by the side. And hopefully that looks something like a reasonable bow tie, okay? Now, the next thing you need to do is you need to work out the gradient of the straight line. And to work out the gradient of the straight line, I use the formula rise over run. Okay, now to do that, I need to draw a nice triangle. So I look for a point where it's going through one of the bold lines, and I'm going to go up to my next bold line and just check it goes through nicely there on a point. And I think it does. I think it goes nicely through that point there. So I'm going to draw a triangle like that. Okay, now if it hadn't, I would have just gone up again and then come over to here. But if you look here, if I zoom right in with the camera, focus that, I don't like that point there because it's going halfway through a square, so I wouldn't like that one, whereas this one here did actually cut the square right there. So what I need to do now is work out what the rise over the run is. Now, I know how much that has risen because it's gone one block, and I know one block is worth 5. What I need to do is work out how many little squares fit in here, which is 1, 2, 3. Oh, hang on, I'm counting really bad here. 1, 2, 3, 4, 5, 6, 7. For me, I make mine 7 little squares. Let's just double check the scale. In between 0 and 20 is 10. So each little square is worth 1. So that is 7 little squares is worth 7. So then to work out the gradient of that, how much has the graph risen? 5 over how far it has run, 7. My answer would be 5/7, but as long as yours is what you've got from your graph, you'll get the marks there, okay? And that would be ms to the -2 for your deceleration. The next thing we're asked for in part B says calculate an estimate of the distance travelled by the train from the instant the brakes are applied until it comes to rest. You must use exactly 4 strips of width. Okay, so this is when the brakes are applied until rest. So to work out 4 strips, we look at the distance that we travel from 0 to 80, and we split it in 4, okay? So 80 divided by 4 is 20. So what we do is fire lines up every 20 until we hit the graph. So 1, 2, 3. Don't need to do it at 0 or 80 because they're already there for us. And then we've got 4 strips. So we're going to call that A, B, C, and D. Okay, the one thing I will say is that those 4 strips are quite wide. You usually have them a bit smaller to be more accurate, so it's not going to be hugely accurate. It wouldn't surprise me if that was a question that comes up. So from here, what we need to do now is use the trapezium rule to work out the area of each of these. Okay, the formula of working out a trapezium is for area is a half A plus B, which are the parallel sides, times by height. The parallel sides of this trapezium here is this side here and this side here. Now that goes up 2 little squares. Let's check the scale. Jump of 5, 10 little squares tells you that each square is worth 0.5. So that is 36. Okay. Now this is 2 little squares underneath, so that is 34. So for my first one, it's going to be 36, add 34, times by a height. Now because we did 80 divided by 4, they're all going to have a height of 20. Okay, I'll put that into my calculator towards the end and I'll just do them all in one go. For B, it's going to be a half. Now whatever that number ends on, you notice A and B have the same line shared. So whatever that one ends on, this one will start with that. So 34 plus this number here, which is 2 under 30, so that's 29, times by 20. For C, I know it's going to be a half of 29 plus, it ends on 20, times by 20. And for D, it isn't actually a trapezium at all, it's a triangle, so it's just going to be a half base times height. So the height is 20 and the base is 20, so it's just going to be a half brackets 20 times 20. Okay, so into our calculator goes all of those. Half brackets 36 add 34 times 20, 700. I'll use the replay button to make my life a little bit easier here. So change that to 34 plus 29. 630. And then 29 add 20, 490. And then a half of 20 times 20 is 200. To then work out the total distance, I just add those 4 strips together. So it's going to be 200, add 490, add 630, add 700. And I get 2,020 meters. Okay? Now, we're then asked in the next question, it says, explain how you could use the graph to gain a more accurate estimate for the distance travelled. So that's exactly what I was banging on about before. More strips would be more accurate. Okay, it would be a lot more work as well. So if we had done them in strips of heights of 10, we'd then have had 8 bars to do. So we'd had twice as much work to do that we just did. Okay then, we are on to the very last question. Now, have a read of the question, try and get your head around it. I'll start going through it in about 10 seconds. Okay, it says, gardeners can apply weed killer to areas of land by using a spray gun. Weed killer is stored in a large bottle that gardeners carry on their backs, and this feeds the spray gun. A gardening company has designed a bottle shown below. It consists of a hollow cylinder and a cone that are joined. We're then told that the base of the radius of the cone and the radius of the cylinder are both 9 centimeters. So what I'm going to do is go and draw that in. Okay, so there is where they join. That distance there, the radius there from the center, is 9 centimeters. So I've dealt with the first bit. It then says the height of the cylinder is 4 times the height, 4 times the vertical height of the cone. Okay, so this height here, vertical height, so that would be at 90 degrees there, and then this height here, this distance here is 4 times that height. Now, be careful with this. They've done this on purpose. It's for you to create a bit of algebra here. If we call this h, it's 4 times bigger than that, so that would be h divided by 4. I don't really want to deal with fractions, so I'm going to call this h instead, and this would be 4 times bigger than that, so this would be 4 times whatever that is, so 4h there. Okay? Now, we're then told the bottle has been designed so that it has a capacity of 10 litres. You need to know the following conversion, that 1 litre is worth 1,000 centimetres cubed. It's something you're expected to know. So therefore, 10 litres must be 10,000 centimetres cubed. And that's important because that's in centimetres there, okay? So we want to be consistent with the level of units that we're using. What I'm going to do now is write down a formula to work out what I'm told already. So I know that I've got a cylinder. I know that it's attached to a cone. And I know that gives me a capacity, a volume of 10 litres. Okay? Now, if I write this in here, what these formulas are, the formula for the volume of a cylinder is pi r squared, so pi 9 squared times by the height. I don't know what the height is, but I do know it algebraically is 4h. Okay? I now need to add the volume of the cone. Now, that is given, just looking, to try and get it ready there, that is given here. It tells you that it's a third pi r squared times by the height. Okay, so I want to do a third pi radius, which is also 9, times by the height, which is h. That's equal to a volume of 10 litres, which, because that's in centimetres, this would now go to 10,000 centimetres cubed. Okay, I'm not going to put the centimetres cubed in. There's no need to do that because we're just going to work with numbers for now, but they're all consistent numbers. Okay, now, we've got a slight problem here. We can't work out this, however, you can work out more or less all of it. If I say shift pi 9 squared, which is 81, and then I obviously can't do 4h. If I just do the 4, that will tell me that it's 324 pi h. That h just come on the end here. I then want to add on something very similar, so I do a third pi, brackets 9 squared, and then h hasn't got a number, it's just 1, okay? So I don't need to times by 1. If I work that out, I work out the volume in terms of pi and h is 27 pi h. That is equal to 10,000 centimetres cubed still. I can now merge those two together. So 324 pi, add the 27 pi, comes to 351 pi h is equal to 10,000. So then to work out what the h is alone, I'm going to get rid of this 351 pi, which is timesing by the h. I'm going to get h is equal to 10,000 divided by 351 pi. So 10,000 divided by 351 gives me an answer of 9.0686 blah 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 centimeters. Okay, now that's what this height here is. That's 9.06, and you'll notice that I haven't rounded yet. The reason why I haven't done that is because I haven't finished the question. It says what is the total height of the bottle. So the total height of the bottle is all of this. So this height here is 4 times that, or we could say that 4 height plus a height would be 5 height. So the total height of the bottle would be 5 times that 9.06 blah 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 number. Okay, so if I do 5 times that answer without rounding it, I'll get my most accurate answer, which would be 45.34 to 2 decimal places. Okay, and that's how you work that out. But quite a hard question now, not an easy one at all. Okay, we're then told wheat skillet is poured into the bottle at a constant rate. The cone is full after 2 seconds. The bottle as a whole is full after 26. Using the axes, sketch the graph of the height of the wheat skillet in the bottle during the 26 seconds it takes to fill. Now, if you look at the axes here, it's split into 1, 2, 3, 4, 5. That's not a coincidence with this bit here that's 5h, okay? We know that this is just 1/5 of that, 1/5 of the height, so and it's full after 2 seconds, so 1/5 of that, that's when the cone gets full. So we know that the cone gets full after 2 seconds for 1/5, and then that the entire container is 26 seconds, and it gets full here, there. Okay. Now the cylinder is what we call a prism because it has a constant cross-sectional area. So when that gets filled up, it will just fill up like a glass of water does, very, very linearly. It'll just be a straight line connecting those two because it's a nice normal shape to fill up. So I'm just going to connect those two there. So I'm going to do the second bit first. It's actually the first bit that's going to be the pain to work out what's going on. Now, if you think about pouring water into that, it's very skinny at the bottom. So initially it's going to fill up really quickly, but as it gets wider and wider and wider, that's going to slow down. So what we're expecting to see for that volume is that it goes flying up and it starts to slow down in terms of how quickly it fills up. So your shape for the first 2 seconds has to resemble something like that, and then a nice straight line, okay? And that was the final question. Hopefully you found that useful. If you did, please hit the subscribe button to get access as and when I release more videos. Thank you very much for watching.